Hello, you guys. Let's talk about Chapter 9, Lesson 4 on real numbers. So the first really important part is the vocabulary. You have to know what an irrational number is and then what real numbers are. And that's why I put this drawing here, okay? So please copy it down in your note-taking guide. And this is how I like to start off. Let's look at the smallest little oval here, the whole numbers. Remember, whole numbers would be 0, +1, +2, +3, and so on. They're whole complete numbers. They're like the numbers you first start learning about when you're learning how to count and all of that. Now, integers, that's when you grow up a little bit more and you learn about positive and negative whole complete numbers. So integers are all the whole numbers and their opposites, like 2 and -2, 8 and -8, and so on. Okay? Then you learn more about math and your brain kind of grows here, and that circle grows. You learn about rational numbers. Now, rational numbers are any numbers that you could write as a fraction. Look at the first 5 letters, R-A-T-I-O. That means all of these numbers are rational because you could write an integer as a fraction, right? Like the number 7, you could write as 7/1. So rational numbers are positive and negative numbers that you could write as fractions. Okay, now over here, look at this weird little circle off to the right here. Those are irrational numbers. And irrational numbers are like pi, okay, above my door in my classroom. They are decimals that never end and never repeat in a pattern. But the reason they're bringing it up here in Chapter 9 is because they're also square roots that are not perfect. And then all the rational numbers and irrational numbers create what we call real numbers. And so look in the vocabulary. Irrational numbers can be decimals that never end and never repeat in a pattern, so you can't put the repetition bar over them. Or they're non-perfect square roots, the ones that we have to estimate. And then, of course, real numbers just means you take all of the rational plus all of the irrational numbers, and that's what makes real numbers. All right, take a look at example 1, classifying real numbers. This is kind of the easy part. Look at A. If I give you 7/10, you should know right away it looks like a fraction, so it must be rational. They're showing you another way to do it. If you changed it to a decimal, 7/10 would be 0.7. And so it's what we call a terminating decimal. It stops, and it's rational. But you knew that right away because you saw it was a fraction. Take a look at B, 2/9. Again, you should say, it's a fraction, it's rational, and you're right. As a decimal, it looks like 0.2 repeating. And so anytime we use a repeating bar, it's rational. Okay, so look at example C, radical 5. Now, radical 5 is not a perfect square root. So if I used my calculator, and you can try this at home, you would get 2.23667 ... It never ends and it never repeats in a pattern, or we could use a repetition bar. And so that's what we would say is irrational. Now you could tell me right away it was irrational because it's not a perfect square root. Okay, what if they ask you in example 2 to compare real numbers? So if I want to compare radical 3 with 6/5 on a number line, well, you can use a number line or we can just estimate these, okay? So take a look at radical 3. If I want to estimate it, remember, I would surround it by the perfect squares. So it's really close to radical 1 and radical 4. Well, radical 1 is the same as 1 and radical 4 is the same as 2. Now, if I have to say who is it closer to, of course it's closer to 2. So I would say radical 3 is about 2. And so if I graphed it on a number line, I would just put it closer to 2 than it is to 1. Now, 6/5, of course, is 1 1/5, which is 1.2. And I know exactly where that is to graph it. And so, anyway, and you guys would know this too, since radical 3 is closer to 2, it has to be larger. So the square root of 3 is greater than 6/5. Okay, so I'm going to have you write the movie clue over here where I cross this out later in the movie. You'll write it right here. Okay, take a look at the checkpoint. And sorry about the copy here. My original PDF was not very good. It was, I had to insert this page. So anyway, sorry about that. All right, take a look at checkpoint number 1. They just want us to tell whether they're rational or irrational. So very quickly, 8/11, it looks like a fraction. It is a fraction, so it's rational. On number 2, radical 7. If radical 7 is not a perfect square root, so it's irrational. Number 3, radical 49. Of course, that equals exactly 7. It's a perfect square root, so it's rational. And then for number 4, radical 2 over radical 5. Remember, split it up, radical 2 over radical 5. Well, radical 2 is irrational. Radical 5 is irrational. So that makes the whole thing irrational. And then take a look at number 5. Negative 3 over 2 is the same as negative 1.5. And then negative radical 3, well, we already said that radical 3 is close to radical 4, which means it's close to 2. So negative radical 3 would be close to negative 2. And since negative 2 is smaller than negative 1.5, we would have to put the is greater than symbol to show that negative 1.5 is really larger. And then take a look at number 6, radical 10 compared to 3.5. Well, you know radical 10 is close to radical 9, so this is close to 3. So if radical 10 is close to 3, it's got to be smaller than 3.5. Okay, let's talk about this checkpoint. This can be really tricky for people. They want you to use a number line to order the numbers from least to greatest. I'm not going to have you do that, but I am going to teach you a little trick. See these square roots? We kind of want to get rid of them, especially if they're not perfect square roots where we'd have to estimate. So another way to compare these is if we square every single one of these. If we square them and then compare the values, we can still put these numbers in order. So 5.9 squared would be 34.81. And you could use the table to help you, or you could just multiply it out. That's not a hard one. Now, what happens with 3 radical 5s to the second power, you have to think of the rainbows. You give the second power to the 3, and you give the second power to the 5, okay? The radical 5. So 3 to the second power is 9. Radical 5 to the second power is just 5. So 9 times 5 would give us 45. And then 5.4 squared is 29.16. And radical 35 squared, remember the square and the square root destroy each other, so that's just 35. And then you can put these in order. So see how 29.16 is the smallest, so I know that 5.4 would be the smallest, and so that would be 27 over 5, because that's 5 and 2/5, and that's 5.4. So I put it back in its original form. And then the next number that I would have to pick was the 34.81, so the 5.9 would come next. And then the next number would be 34, so the radical 35 would come next. And then the biggest number there, of course, would be 45, so that's why I put 3 radical 5 last. Okay, so look at example 4, using irrational numbers. So after an accident, a police officer finds that the length of a car's skid mark is 98 feet. The car's speed in miles per hour and the length in feet of the skid mark are related by this equation. S equals radical 27L. Find the car's speed to the nearest tenth of a mile per hour. So I start off with the equation S equals radical 27L, and then I substitute in the value for L, the 98 feet, and I multiplied under the radical, so I got radical 2,646. And then I used a calculator. I'm not going to expect you guys to do this without a calculator. Or if I asked you to do it, you could use that table that I gave you. But this would be about 51.439. And so I just rounded that. It's about 51 miles per hour. That was the car's speed before the accident. Okay, in the movie clue, I want you to write it where I showed you earlier. And I want you to write just one example of an irrational number.